Earth Systems 3209, Unit 1, Introduction to Earth Science, the Evolution of Planet Earth. Text references include Chapter 1, Chapter 17, Appendix A, and Appendix B. Focus of this topic, Topic 1, Section 2.4, centers around Earth's interior. We will focus on recognizing that Earth's geosphere has a layered interior. We will identify the characteristics of each layer, and we'll also focus on drawing a diagram representing the Earth's interior. Let's first look at the Earth's interior. This model of the Earth's interior is based on indirect evidence. That is, nobody could ever get down inside the Earth to actually visualize what the Earth's interior looks like. Therefore, we have to rely upon evidence collected from exterior sources, such as seismic waves. This diagram to the left outlines four main layers inside of Earth, those being the crust, the mantle, the outer core, and the inner core. Text references can be seen on page 19 to 23 and page 475 to 477. When we look at the layers of Earth's interior, the lithosphere is a cool, rigid layer directly above the asthenosphere. It is approximately 100 kilometers thick, which includes the entire crust portion and the uppermost mantle. Referring to the diagram, we can see that the lithosphere would extend from this region down to this region, which would include approximately 100 kilometers depth down to approximately 700 kilometers deep. The crust is one part of the lithosphere, and there's two types of crust. First, we have the continental crust, which extends from approximately 30 kilometers to 40 kilometers thick and has a very low density. Beneath that, we have the ocean crust, which is only approximately 5 to 7 kilometers thick and has a relatively high density. In the diagram, we can see the corresponding continental crust located within the continents and has a thicker composition, anywhere from 30 to 40 kilometers thick. And the oceanic crust is relatively thin, which extends only about 5 kilometers thick. Beneath the crust, we have a boundary, which is not a layer, but it's just a boundary that separates the crust from the mantle. This boundary is called the Moho-Rivik discontinuity, Moho for short. It is distinguished by an increase in rock density, and this is due to velocity of seismic waves, which show an increase as they move through the crust into the upper mantle called the asthenosphere. Beneath the Moho is a layer called the asthenosphere. The asthenosphere is a hot, weak zone of rock that is capable of gradual movement. This is the layer that crustal plates rest upon and is responsible for moving crustal plates. The asthenosphere is located from approximately 100 kilometers depth to approximately 700 kilometers depth. In the diagram, we can see that the mantle is located beneath the crust and above the outer core. The asthenosphere represents the upper region of the mantle, extending down approximately 700 kilometers in depth. Beneath the mantle, we have the lower mantle. This consists of a high-density rock rich in compounds of iron, magnesium, and silicon. This layer is approximately 2,200 kilometers thick and is located in the lower region of the mantle, directly below the asthenosphere. Beneath the lower mantle is a region called the outer core. The outer core consists of a liquid nickel and iron, and it is the only layer within Earth that is a liquid. It is approximately 2,270 kilometers thick, and seismic waves, we call S waves, do not pass through this layer. This is a topic that will be discussed at a later time. Beneath the outer core is the innermost layer called the inner core. The inner core consists of solid iron and nickel and is approximately 1,216 kilometers thick. This is the innermost layer of Earth and is found directly in the center, below the outer core. Another aspect of the Earth's interior that we should look at this point is temperature and density. And we see that both temperature and density increases with depth inside the Earth. Temperature inside the Earth increases at a rate of approximately 35 degrees Celsius per kilometer. And this is what we refer to as the geothermal gradient. When looking at density, density inside the Earth also increases as depth inside the Earth increases. Referring to our diagram, we can see that the average crustal density is approximately 2.8 grams per cubic centimeter. When we look at the mantle, which is located beneath the moho, which separates the crust from the mantle, our density is approximately 4.5 grams per cubic centimeter. Moving to the outer core, which has a density of approximately 9 to 10 grams per cubic centimeter. And finally, the inner core, which has a density of approximately 13 grams per cubic centimeter. For students' purposes, when we look at temperature and density, we just need to look at the relative densities and relative temperatures as we go from the crust to the interior of the Earth, and both temperature and density increase with depth inside the Earth. Let's take a look at some sample public exam questions. Example number 1. Which layer of Earth's structure is represented by X? Referring to the diagram of the Earth, X points to the innermost layer of Earth. Our choices would be A, asthenosphere, B, inner core, C, lithosphere, or D, outer core. By looking at the diagram here and the explanation that was just provided, the inner core represents the innermost layer of Earth. So in this case, our answer would be B. Example number 2. Which best describes continental crust? Our choices include 7 kilometers thick with a high density than ocean crust, 7 kilometers thick with lower density than ocean crust, 35 to 40 kilometers thick with a higher density than ocean crust, or D, 35 to 40 kilometers thick with a lower density than ocean crust. When looking at some of your answers to multiple choice questions, we notice that both A and B start with 7 kilometers thick, and then they have differing densities. Also, answers C and D have corresponding 35 kilometers to 40 kilometers thick, and then they have higher and lower densities. So the first thing we need to do is identify if the continental crust is thick or thinner in relation to the ocean crust. And from the diagrams that we previously looked at, we know that the ocean crust is thinner and the continental crust is thicker. So therefore our answers should be limited to answer C or answer D. Next we look at the determining factor. does the continental crust have a high density than the ocean, or a lower density than the ocean? Where the continental crust sits directly up on the ocean crust, it has a lower density than the ocean crust, and in this case our answer would be D. Example 3. Which is the correct sequence of Earth's layers from the surface to the center? In this case, we need to look at the answers. Answer A says crust is closer to the surface, and it progresses to mantle closer to the center. B says crust is closer to the surface, which then progresses to inner core, which is closer to the center. C, mantle is closer to the surface, and outer core is closer to the center. And D, mantle is closer to the surface, with the crust closer to the center. Again, as in example number 2, we say that answers A and B start off with crust, which is close to the surface, or C and D, which is mantle, which is closer to the surface. From going over the diagrams and the preceding slides, we know, or we learned, that the crust is the outermost layer of the Earth. Hence, we can conclude that A or B is one of the correct answers, eliminating answers C and D. If we look at the layer closest to the center, we see mantle and inner core. And from the slides that we previously looked at, the inner core is the innermost layer of the Earth. Therefore, example number 3, B is the correct answer. Your turn. Take some time and complete the following questions. Solutions will follow. You can pause your recording now while you answer your questions. The question asks to draw a well-labeled diagram outlining the layers of Earth. When we draw a diagram of the Earth, we could start off with the innermost layer, followed by the next most layer, and then a relatively thicker layer, and then followed by a relatively thin layer. Labeling these layers, the outermost layer would be called the crust. The uppermost part of the second layer would be the asthenosphere. The lower layer of the mantle region is labeled lower mantle. Followed by the outer core, and finally the inner core. Also, you should note, in between the crust and the mantle region itself, there is the boundary, which we call the moho. This diagram represents the major components that you need to draw when you draw a labeled diagram of Earth's crust, or of the Earth's interior. The outermost layer would be the crust, which consists of 2 layers, the continental crust, which is the uppermost crust, and the ocean crust. The boundary which separates the crust from the mantle, which is the moho. The uppermost mantle, which is the asthenosphere. The lower mantle, followed by the outer core and inner core. You can also take another opportunity to complete another question. Take the time to complete this question. Push pause now and refer to the next slide and answer the questions that follow. When we answer the questions that follow, we want to label the parts of the Earth's interior. The outermost layer here we refer to as the lithosphere. The lithosphere is the outer 100 kilometers of the Earth, and we commonly call the lithosphere the crust. Below the lithosphere is a boundary called the mohole, which is not labeled in this diagram. We also have the uppermost mantle, which is called the asthenosphere, the lower part of the mantle, which we call the lower mantle, the outermost part of the core, called the outer core, and the innermost part of the core, called the inner core. Also, you should note that the density. Here we do not need to be so specific to say that the density of the lithosphere is 2.8, the density of the inner core is 13 grams per cubic centimeter, but relatively that the outermost portion of the Earth, the lithosphere or crust, has a low density as compared to the inner core, which has a high density. Therefore, we see that density increases with depth inside the Earth. We can also make this distinction with relative temperature. If we look at the outermost layers, the lithosphere, compared to the inner core, we will notice that the relative temperature from the Earth's surface, the lithosphere, is also low, and it increases with depth towards the inner core. For homework, before next class, you can take the following chart and fill in the missing parts. We're looking for materials that make up each of the layers. We're looking for the state of the layers, the density, relative density of each layer, again, low to high, and the relative temperature of each layer, low to high. Fill these in the chart for homework. In summary, an overview of the points that are covered in this presentation. The Earth's layers include, from the surface to the innermost layer of the Earth, we have the crust, which contains continental crust and ocean crust. We have the upper mantle, which we call the asthenosphere. We have the lower mantle, followed by the outer core and the inner core. Also worth noting here is temperature and density both increase with depth inside the Earth.